Sr.Brit, can you start,
All right.
please?
Okay. Thank you, Mr. Hideo Sakamoto. Before I start, I would like to say thank you very much for the invitations for this particular sessions. I feel very humble. I'm not saying I'm expert in the particular heritage conservations, but with my patience today, I hope my sharing will give you some solid insight into what's going to happen in upcoming years, in particular heritage conservation in Malaysia in general, as well and in Malacca as a specific way of conservation as per now. Just a brief of introduction of myself. I'm Brit Kayan, just call me Brit. I'm attached to the University of Malaya under the Faculty of Built Environment, serve for building surveying department for this year is 22 years. Okay, my PhD was on the construction management, yet focusing on the heritage conservations, particularly looking for green maintenance model application as well as sustainable material as well as sustainable repair. Currently, most of my research focus is more on the quantification of embodied carbon expenditure from the usage of traditional repair and as well as traditional materials in the heritage conservation. So I am a surveyor in professional recognition by Royal Institution of Surveyors Malaysia, as well as I'm a registered conservator under the uh, uh, Ministry of Tourism, Arts and Culture of Malaysia. All over Malaysia's the recognitions by the MOTEX for the registered conservator all over the country. Not very much of us. It's about nearly 50 of us as a registered conservator in Malaysia. So I'm very happy to a part of team of a registered conservator in Malaysia. So today, again, thanks for the opportunity given to me, particularly by the Master Sumata and the teams. And I do hope that my presentation later will be beneficial to everyone, as well as not to say it's a one way of communication. I do hope that during the Q&A would be your response to this particular presentation will give me a new ideas, new knowledge with regards to the build heritage and heritage conservation. All right, so I will start my presentations. I will share you in shortly my presentation slides. Just to check, can you see my presentations? Yeah, slides on your screen.
Yes, sir.
Okay. As usual, I would like to say selamat datang. Selamat datang is a welcome in Malaysia or Malay terms. Mr. Sakamoto, my apology if my pronunciations of Japanese language is not so good, but I try to say irashasimase. For those who speak in Chinese, right, Mandarin, whatever, I want to say Huan Ying, and of course, wherever you are, good evening, good afternoons. Might be some of you in your country still morning. I don't know. I want to say welcome to this presentations. The entitles of the presentation is Green Maintenance Models in the historic city of Malacca, Malaysia. In the case of low carbon laterite stone repair. So the outline of the presentation covering 6 main areas. One, I'm talking about the historical city of Malacca itself in a brief manner. Of course, a very brief way of introductions of the historical city of Malacca. Then so we move on to the very basic understandings on laterite stones, in particular Malaysian laterite stones context. Then followed by green maintenance and low carbon repair. This particular area I want to share in terms of general understandings what is a green maintenance and low carbon repair approach. Then all of this will be aligned well with the case studies or the practical examples of how green maintenance and low carbon repair with regards to the low stone repair, low laterite stone repair, right? With the brief sharing of a few case studies, as well as to show how this green maintenance and low carbon repair can be a practical adoptions with regards to the quantification of environmental maintenance impact evaluations. I will share in item number 5. And last but not least, I will wrap up these particular presentations with the how could we look into the way forward in terms of low carbon cost repair in heritage conservation. Now, I would like to start with the brief introductions of historical city of Malacca. Historically, right, since 1800s, Malacca is under Malacca Sultanate establishment or Malacca Sultanate Kingdom. Then it is spanned during the 15th century. It became a capital city. One of the important aspects of historic city of Malacca is that in this 15th century period, it became important shipping ports during the Sultanate Empire, covering most of the Malay Peninsula, right? As we know, covering as well the Riau Islands in Indonesia. You can see from the slides around this area, as well as up to the northern of Sumatra of Indonesia. So again, in 15th to 16th century, there's a major transshipments between Asia and Europe, either by Indians, Arab, Chinese, and European merchants, particularly through this Selat Melaka, whereby all the tradings pass through this Selat Melaka, as well as in that particular times, Melaka becomes a very important port for this particular trading between all the West and the East country. As you can see from the photo, is the impressions Melaka at that particular times during the 15th to 16th century is one of the busiest ports. That accommodates the requirements or the demand from the important shipping ports and trades. Okay, when you look into the Melaka history, right? So I want to put into two particular era or wisdomly we can call it during the Malacca Sultanate as well as Malaya. Okay, since 1400 century, right? Is under Malacca Sultanates, and due to the status of the very busy spot for trades and so forth. Okay, one of the reasons Portuguese in 1100s, okay, and until 1641, okay, is merely about 130 years. Okay, Portuguese have occupied Malacca, right, and then followed by the Dutch, okay, about nearly 140 or 46, 45 years, okay, of Dutch occupations. And when it came into Malaya, okay, after the 1786 until 1942, under the Anglo-Dutch Treaty between British as well as the Dutch, this is under occupation of British, nearly 160 years. And then so during the World War II, very briefly, or about 3 to 4 years, Malacca had been occupied by Japanese. And then when the World War II ended in Malaya at the particular times, Malacca is under jurisdictions of British Crown colony in 1946 until 1957. So what I try to emphasize of this particular chronological history developments of Malacca is that due to the occupations of colonizations that nearly 500 years, will give the richness in terms of the architectural influences, styles, form, design, either is tangible or intangible diversity in Malacca that we can see from the building or existing stock in heritage building in Malacca at present day. Now, just a brief on Malacca. Okay, located one of the states on the west of Malaysia, in Peninsula Malaysia. Okay, the neighboring country is on the north is Thailand, and then at the south is the neighboring country is Indonesia. Okay, now Malacca is one of the historical city in Malaysia because I want to highlight is that it's covering to the north. If you can see from the maps on the north is until up to the area of Durian Tunggal and up to the Teluk Mas at the southern is with the neighboring states of Johor. On this particular photos, as you can see from the aerial view, you can see there's a group of buildings. Okay, as you can see from here is where the historical city of Melaka comprises of different types of heritage buildings, which covered other is a core zone and buffer zones of World Heritage Sites. So where I can share with you in the other slides later on. Okay, quite historic in 2008. To be honest, I'm one of the teams that managed to prepare the dossier for the nominations for both Malacca as well as Penang, Georgetown Penang, for the nominations of UNESCO Heritage Sites. So in 2008, we managed to get the inscriptions from the UNESCO for the Malacca to be inscribed as a UNESCO World Heritage Site or WHS, as covering core zone and buffer zone with the total area of nearly 290 hectare of area. If you can see from here, is covering the two main area of St. Paul Hill Civic Zone, as well as on the north is residential and commercial zone. So you can see from the residential and commercial zones, okay, these two areas for the inscriptions of World Heritage Sites in historical city of Malacca, covering St. Paul Hill Civic Zone, as well as residential and commercial zone. If you look into the proportion of the total number of buildings for both core zone and buffer zones at the historical city of Malacca, at the core zone comprises of about 930, as well as buffer zones about 948, totaling about 878 buildings, okay, located for this particular area of core zone and buffer zone at this particular Malacca historical city. All right, why Malacca is get inscriptions of World Heritage Sites? Comparatively, if you will look into the perspective of World Heritage Site all over the world, okay, the inscriptions during the nominations will consider the outstanding universal value, or called OUV, that inherited by the particular places. For example, in the case of historical city of Malacca, what I want to emphasize is here, right? Historical city of Malacca not only managed to have one criterion that at least minimals for the requirement of inclusion of World Heritage Site, but historical city of Malacca gained more than once OUV that I will share or give into insight shortly. One of the criterion is the Malacca itself represent exceptional examples of multicultural trading towns, particularly in regards to the in East and Southeast Asia. During this particular, let's say, like I mentioned before, during the 15th to 16th century, is forged from the mercantile exchange from either Malay, Chinese, Indian cultures as well as during the colonial occupations, including Portuguese, Dutch, and British, Japanese, and British again. So nearly European colonial powers for almost 500 years, whereby due to this particular colonizations, okay, Malacca imprints the architecture and urban forms, which is unique in terms of the technology as well as the most important monumental art. So as you can see from this photo I inserted here, how Malacca develops, okay, as a representing all the exceptional examples of multicultural tradings. You can see all the merchants coming from all over the world, particularly the Chinese, Malay, Indians, as well as from the Arabic countries at one time, as well as the colonizations that enrich the original examples of multicultural trading for this particular historical city of Malacca. The second OVB criterion covering living testimony to the multicultural heritage and tradition of Asia and European colonial influences. I insert a few examples over here, a few buildings that give us a multicultural, either is a tangible and intangible heritage, whereby all of these buildings express in great variety. Either they are religious buildings of different faiths, ethnic quarters, languages, worship and religious festival, dances, costume, art, and so forth. But here I want to highlight a few examples of buildings that incorporate with this particular living testimony to the multicultural heritage and tradition of Asia, as well as European colonial influences, including Cheng Hung temples with elaborated decoratives established in 1645. We do also have in Malacca Sri Poyata temples established in 1710. Okay, most elaborated mosques, one of the earliest mosques in Malacca, the two earliest mosques in Malacca, including the Kampung Hulu Mosque as well as Masjid Kampung Keling, respectively established in 1728, as well as Kampung Keling in 1748. As you can see, there is a multi influence by the either is from Chinese influence, Arabics, as well as Malay architectures. Okay, so for this particular mosque building, of course, just a quick examples, quite prominent. As we know, Malacca at one time occupied by the Dutch. So one of the significant example we do have in Malacca, Christchurch, with the Dutch architectural influences, built in 1753. So the third one is Malacca, historical city of Malacca, in terms of OEB, reflect a mixture of influences that created unique architecture, culture, and landscape without parallel anywhere in East and Southeast Asia. Means Malacca is very unique in such a way they demonstrate exceptional range of shop houses and townhouses. As you can see from here, right, built 1890s to 1920s, we can see the transitional shop houses as well as neoclassical shop houses elaborated with decoratives, with a very unique motif from their facades. Okay, and of course, during that particular historical development of Malacca, as you can see, also it shows many different types of stages of development of buildings, particularly during the occupations, either during the Dutch or the Portuguese periods, including State House, 1640, a Formosa, built in 1512, as well as St. Paul Church, 1521. All right. The second area I want to share a bit is in terms of laterite stones, an overview with regards to the Malaysian laterite stone profiles in particular. As you can see from these particular photos, okay, what I try to share is that how Malaysian laterite stone formations, okay, in particular the investigation we do at the fieldworks, we can divide it, the formations of Malaysian laterite stones, okay, the profiles on the top of the soils is inclusive with the vegetation layer. Number two is brittle and loose soils. Then the deeper it goes, the third layer is brittle but dense of the clay, and then the deeper it goes, the fourth layer is a clay forms. And the photo at your right side, okay, showing how the difference in terms of granular, okay, the particle size of Malaysian laterite stones. As you can see, they are different in terms of the color, the based on the exposure, right? For example, in number 5, you can see the reddish colors, right? For the laterite stones, whereby they expose to the direct sunlight, as well as when we are collect the sample of number 6, whereby it's submerged in water, okay, rather than black in terms of the color of the appearance of the laterite stones. All right. So based on the data that we got from Department of National Heritage of Malaysia or Jabatan Warisan Negara Malaysia, okay, in general, Malaysian laterite stones comprises of silica at 61%, followed by aluminum oxides, okay, at 11%, ferrum oxides 4%, and respectively calcium monoxide as high as 23%. Of this particular profile or combinations of different what you call is chemicals profiles of Malaysian laterite stones, make it one of the hardest or stable in terms of the integrity stones types in Malaysia that are available during the construction of the previous Malaysian bell heritage, in particular in Malacca. As you can see from the photo over here, we can see a few examples of the hollow particles, right? That's a makes the laterite stones in very, very strong in terms of compression and shear strength. As you can see, the applications normally, okay, for fortification, for example, in this case, in Malacca, we do have a fortification like Middleborough, what we call fortifications, as well as bastions in this particular Famosa. As you can see, the applications fortification is very, very good in terms of the strength as well as compression and shear strength. So this is due to the formations of all these chemical profiles that I mentioned just now. Okay, with regards to the process mode of laterite stones, in general, starting from extractions up to the maintenance interventions, in particular build heritage, what we can say is that it involves labeling and marking, okay, and then followed by processing of cutting, trimming, and shaping on sites, okay, either is a traditional way of doing it or using the most advanced technologies with machineries and so forth, okay. You call dressings, and then once you will dress, we'll call into the stages number 3, involving storing for the laterite stone, merely to make the oxidation process and seasoning process, whereby this particular process number 3 to ensure the hardening process to secure the strength of the laterite stone. Right. With regards to the laterite stone, in particular in Malaysian context, I want to share a bit on the traditional quarry. But of course, fortunately, this particular Pulau Upeh quarry, right, had been closed since many years ago. From the historical evidence, okay, most of the laterite stone used in Melaka area, in particular for the Famosa and the rest of the buildings in the St. Paul civic zones, using laterite stones quarried from Pulau Upeh. Just if you are using boats of this particular Pulau is an island, okay. It took us from the earliest we call wharf or boat jetty. It took around 45 to 1 hour, okay, travel by boat to this particular island. I want to emphasize that at the present day, Okay, this particular traditional quarry of Pulau Upe has been submerged under the seawater. So if you want to do inspections, like in our previous research on this particular Pulau Upe traditional quarry of laterite stones, we need to work hand in hand with the Geometric and Land and Survey Department of Malaysia, as well as local villages or fishermen around this area to know what's the best time to visit this particular traditional quarry. So that's during the water recess, only that we can see the evidence, okay, the tracks of the evidence of the previous mining or quarry activities or for this particular traditional quarry of Pulau Upe. Quite interesting. If you can see, there's a lot of evidences we can find from this particular traditional quarry or mining that showing how the traditional quarrying have been done and during the historical previous day. So all over Malaysia, Malaysian built heritage, they are using quite a number of the sites or buildings or built heritage using the laterite stone as their main traditional material for element and structures. Either they are temples, for example, in the case of in Bujang Valley, in northern part of Malaysia, in Kedah in particular. Also, for the rubble laterite stones, some of them have been used to make the boundary walls for Lukut Fort in Negeri Sembilan, neighboring country, state of Malacca, as well as been used at Supai Fort in Malacca, and various structures or built heritage, including bastion and fortification in Malacca, right? From these particular maps, okay, as well as from the particular photo, as you can see, there is a diverse applications of laterite stones in Malaysian built heritage. Okay, so with regards to the laterite stones, I want to share a bit how can we study much on the common techniques to repair the damage or laterite stones. One is scenario one is a stone replacement. All of these scenario I will discuss later with regards to the how we can evaluate environmental maintenance impact generated from this particular scenario of repair for the laterite stone. Of course, number one, you can have a stone replacement whereby we use a very durable when suitably matched stone have been used. Normally, for this particular techniques, we need to cut back of 75 to 100 mm in terms of depthness into the historical patina of the wall, for example, right? In normal cases, it's about 0.1 meter depth, right? Followed by an indenting process. With regards to the embedded carbons, the generated embedded carbon for this particular stone replacement is quite considerable, and then life expectancy quite good. Okay, sometimes there are few cases of historic building. They are performed very well, and beyond 100 years, these stone replacements can achieve, let's say, more than 100 years. Okay, as comparative in terms of the bonding types for stone replacements, I want to share with regards to the difference in terms of the bonding types during the Portuguese era, Dutch era, and some of the formation we found from our investigations. Okay, they are also non-uniform or mixed bonds available of during the investigation upon the several historical structure that use laterite stone in Malacca. One of it you can see for the Portuguese era, there are no clear formations of bonding types. It's just a mixture of nearly to the similar to non-uniform or mixed bond. But I want to highlight is that during the Dutch era, for the enamel layer, this is in alternately between the stretches over here, right, as well as alternately with the headers of the stone. So that's the main difference between the Portuguese era as well as Dutch era bonding types. Okay, for scenario 2, we do have a repeated plastic repair, whereby on this particular techniques, we do need to have a cutback. You can see from the diagram or illustration I showed over here. The dated stones cutback minimum is 15 mm until the sound surface. So to resurface, we need to put into insertions of non-ferrous or armature support. As you can see from here, this is a non-ferrous armature supports, either it's a metal dowel or tying wire, okay, to hold on the plastering, okay, so they will not falling off. So during the resurface, so the life expectancy is about 30 years, and then embedded carbon is quite commonly high, because you can see from this particular example, right, there's quite large area that required for repeated plastic repair. And then in terms of the longevity, is not really good. It is just about 30 years. So there's a quite number of the interventions that need to be done throughout the lifespan of the particular historic structure. So the third one is repeated repointings, okay, whereby for this particular scenario, we need to repair of loose, open, and soft crumbles and wash out a bedding and jointing of the mortar. Involve cutting and racking out to reach a sound mortar in the depth of the walls. Normally 25 mm okay, to be rack out, right? And then much less embedded carbon expenditure. And then unfortunately, normally the longevity of this particular repair in the region of 25 years. As you can see here, we're looking into the early mortar jointings that we found from the case studies, showing about 10 to 20 mm of pointing size. All right, that the fourth one is a consolidation, then the stone replacement to stabilize the string masonry, whereby for this particular techniques, we need to draw in holes on the delimiting layers for this particular aspect of delimiting layers in or detached section of masonry. And then we injected the modified alarm ground mix. Then we need to put a secondary fixing material, contribute to the high and varying embedded carbon coefficient value. Mean to say, for example, in the case of if you are using a stainless steel threaded dowel or roughly roughened nylons that's surrounded by lime ground. So these two material, in particular stainless steel, normally having a high embedded carbon coefficient value because of the energy that they use during the productions is very high. So that it contribute to very high embedded carbons. Approximately the lifespan is about 20 years. And one important aspect that we need to consider while using this scenario is a repair scenario or techniques is very costly in terms of the labor, because of the nature is very complex and the processes is very difficult and need to be done by the very skilled workers for stone masonry. The fifth scenario or repair techniques, plastic repair and stone replacement using cutbacks, minimum at 15 mm, and then we followed by the resurface, and the life expectancy about 30 years, and then therefore the carbon is commonly high, as you can see here, right? Involved, okay, multi numbers of resurfacing of this particular laterite surface wall, okay. Okay, last but not least is scenario 6. It is reconstructions, normally to repair damage or collapse stone structures. Is it suitable for match stone? Means in terms of the match stone, the surface, the face of the stones should be similar or match to each other. So this particular construction can be done. So it would be good if we manage to match stone that to be an illucarate or salvage, in order for us to cut down the carbon emission or embedded carbon during the construction process. So with mortar jointing, stone laying to reconstruct the Nilu match stone to be done, so that this stone laying or the mortar jointing can be together into the structure. So life expectancy quite good, but the carbon is normally high because we need to reconstruct. So means need to resource, okay, the new materials, okay, that accommodates as far as or similar like to the original's authenticity and so forth. So okay, a very brief on the introduction of green maintenance, low carbon repair, parables to the building life cycle of stages, maintenance, repair, and replacement stages, all the other stage of life of human beings, right? We can say that it's quite similar to the buildings. When it come into the ruinous states, right? Same goes to the human beings. The performance of the buildings getting less or getting lower. So that's why we do need to have a maintenance, repair, and refurbishment to achieve the optimal conditions of the buildings. So again, with regards to the heritage building, we need to consider how it could fulfill the beneficial functions to fit all the uses of function, purposely to fit all the requirements, either by the occupants, users, visitors, and so forth. Okay, so having to say that, if talking about the green maintenance and low carbon repair, of course, with regard to the building conservation philosophy, it's possible we try to achieve the reversible process. What I try to say is that, if possible, the constructions or the conservation of heritage building should be reversible process, whereby, of course, we need to adopt appropriate techniques to achieve, all right, with the technological advancements we could achieve, all right, to ensure either we want to maintain, in terms of the appearance, techniques, material, and so forth, it must be a reversible process. I want to share a bit. Maybe some of you came across or having an experience to watch a movie called The Curious Case of Benjamin Button, whereby we can see the reversible process, whereby in the case of heritage building, I would like to see that in terms of grant maintenance and low carbon repair, can help the heritage building conservation to be regenerated to fulfill might be the new function that accommodate to the new list of life of heritage building. Okay, I'm very quick on this. Okay, normally, what is the embedded carbons? Embedded carbons released during the manufacturing process of construction material transportations. This is according to Samsung Pope 2012, as well as by the ISO 14040. If you look into the longevity of repair and service connection graph, normally when any buildings or any structures came into the ruinous states, so will reach into the minimal acceptable condition, whereby it cannot perform very well in terms of service condition. So that's the existing structure need to be repaired or need to be maintained. So if you can see in terms of achieving the optimal service condition, we need to do quite numbers of repair. The sawtooth representation over here means the more frequency in terms of repair means the shorter in terms of longevity of maintenance intervention. So during the process, right, with regards to the embedded carbon expenditure during the maintenance phase of the buildings, the cumulative embedded carbon expenditure, CE to CE1, CE2, CE3, and so forth, will generated into the total embedded carbons. Okay, so again, in order for us to achieve optimal service condition while the heritage building or heritage structure, nearly reach the maximum acceptable conditions, the continuous repair or maintenance need to be done. But while the process need to be done, we accumulate the embedded carbon emission during the maintenance or repair process. So, of course, the variables during the process, including the longevity of repair, mode of transportation for materials, delivery to building site, resourcing locations, technological developments, other building quality of work and specification, as well as building exposure. So green maintenance in such a way that in general, to minimize environmental maintenance impact, is representing the tripartite approach model, which is during this particular understanding, during my PhD studies there, I formed these particular ideas. It shows us the green maintenance interventions, give insight into how embedded energy appraisal in the form of embedded carbon assimilation or in the form of carbon emissions. So in such a way, while we are doing this establishment of green maintenance model, it will practically determines and ultimately substantiates maintenance decision makings for any parties involved in the heritage building conservation, okay, by using the LCA approach. So with regards to the green maintenance model frameworks, as you can see here, with regards to the LCA approach, starting from the lecturer survey, sample selection, scope outline, up to the answering the questions. Okay, so to determine how can we develop, tested these particular models have been done during my study days. So my case study later on that I'll share with you shortly. Also with these particular models, I want to see how these particular applications of green maintenance models to achieve low carbon repair is feasible in heritage building conservation. So in general, as general understandings, the life cycle assessment will covering from the resource extractions up to the recycling and reuse or disposal. So this is known as an eco-balance or cradle to grave. Mainly the techniques to assess the environmental impacts, of course, starting from the extractions up to the maintenance, disposal, and recycling of the material. So as you can see, this can be represented as well according to the process map of life cycle repair material for heritage building, starting from resource extraction up to the building structures and element repair. So in terms of the research methodology applied, in particular, that we adopted for this particular studies, right? We do have four main process that adhere to the LCA framework. First and foremost, we need to identify goal and scope definitions. Then we need to do inventory analysis evaluated by impact assessments as well as interpretation of the results from the result analysis. On this particular diagrammatic representations, I don't want to go in details, but I want to attach along with these process to LCA frameworks. Okay, for example, in this particular studies that we have from the previous studies from case study that I mentioned shortly, basically comprises of four main process. Of course, one is a cost of this particular to achieve objective one that comprise of a literature review and evaluating of the several parameters. Okay, and then followed by the inventory analysis and stage two, as well as impact assessment by application or adopting of green maintenance models, analysis and testings, and last and not least, for this particular process, we need to have embedded carbon repair strategies, evaluations, as well as how we take along, align with the triple bottom line of sustainability, as well as green maintenance model, tripartite approach that I mentioned previously. Of course, there are two main instruments by using the case study procedures as well as research data. Okay, as you can see from here, right? For the case study, involving wiki, site visit, unstructured interview, as well as fieldwork. One of the main instruments also is research data comprising of just I mentioned over here, including conservation reports, okay, description report, geological information. For example, number 4 here is excavation works, as well as industrial report, so for the materials, right? And then the conservation report for the selected case study. Of course, to support all of these research data, we do need to have secondary data. Either is longevity data, ICE, inventory of carbon energy ICE, as well as transportation data, as well as any previous publications involving published data on repair materials. Right. Again, so I don't want to go in detail on this. What I try to say is that, okay, when this particular process map of the life cycle on laterite stones within the LCA boundary is mapping against the formulation of mathematical formula, okay, to generate the environmental maintenance impacts. Okay, the LCA process map will be aligned with the mathematical equations for these particular studies. We do have about 17 equations. what I want to highlight and emphasize from this equation, we do manage to register this particular formulation into the MyIPO. MyIPO is a Malaysian's intellectual property organizations have been recognized of these 17 formulations as one of the copyrights that's owned by all the researchers, including myself. So basically, these particular 17 equations try to equate or generate or quantify the total embedded carbon exponential for every 1 meter square of laterite stones. And then how can we have a functional units for every meter wall, 1 meter square of wall repair? And then based on the total area of wall repair, then we can generate total embedded carbon expenditure for the whole surface of total area repair. And then to do the testing, okay, we do have the total environmental maintenance impact (EMI) of these subsequent formulations. We have selected arbitrary period of 100 years for the alignment of the different repair techniques with their longevity of repair. So subsequently, in general, of course, the most important thing in this particular green maintenance and low carbon repair, we need to identify the functional unit. In the case of laterite stone, we need to identify how much in terms of total expression of embedded carbon temperature or carbon emission in every 1 meter square of stone masonry walls. Okay, from that, we can test for arbitrary period of 100 years for each of techniques that apply or scenario of techniques applied during the repair. Okay, so the total of EMI can be generated. Okay, starting from cradle to site for each of the techniques applied for any case study buildings. Okay, within 100 years, based on the legitimacy of repair. So then I move on to the case studies. Okay, of course, for these particular case studies, again, like I mentioned before, is located at the coast zone and buffer zone of World Heritage Site of Historical City of Malaya. So it's covering for this particular example I share for this particular presentations is covering a coast zone of area of St. Paul Hill or considered as a civic zone is here marked in red. Okay, the parameters they will look for this particular study is how the exposure to environmental factors, and then to the large and exposed area of laterite stones, as well as one of the important considered parameters or variable in the look for is availability of maintenance records for the laterite stone repair from the collaborative partners. Yeah, the case studies number one, we do have St. Paul Church marked as a CS1. Historically, is one of the oldest European building in Southeast Asia, constructed in 1521. In 1560s, expanded by Dueto Kolho, is a Jesuits using laterite stone. During the Portuguese times, they're having a repair for this particular building using the coral filler, right? And then between the laterite stone by Portuguese and the yellow colored bricks and plaster, you can see from here, right? Yellow colored bricks is during the Dutch occupation. You can see this is considered as called as Dutch bricks, right? And then at one time used as a military base until the demolition of Malaya Fort. Unfortunately, during the expansion of the life of these particular buildings, have been neglected since of the early years until 1930. Okay, but led by the Malaya Historical Society in 1930s, this building have been renovated, and then of course, if you look into the capability of laterite stones for this particular building, it's still standing nobly for more than 500 years through countless conflict and wars. So major conservation in 2001 and 2012. The second case study is CS2 Bastion Middelburg, built in 1641 by the Dutch, designated as a fortification for the Malaya Fort. Of course, using rich iron and alumina, like I said, is very, very typical of the formations and chemical profile of Malaysian laterite stones. Okay, So unfortunately, during the studies, we found that this building facing difficulties in finding the locally available original laterite stones. That's why they're having most of the structure have been reconstructed. Okay, using the imported laterite stone from Sr.Brit, Thailand. So, during the last repair work in 2008. The reason is that because the large amount of the quantity of the laterite stone used to be in this construction work, again, with the Pulau Opeh traditional quarry for laterite have been closed. So that's why one of the resourcing all the most likely similar or like-to-like material that available in the market at the particular time during the 2008, the nearest resourcing location is from Prachinburi, Thailand. So that's for the client at that time is a Department of National Heritage of Malaysia decided to have or use laterite stones manufactured or resourced from Thailand. Okay, the third one marked as a CS3 known as a Famosa is a gate of Porta de Santiago built between 1512 and 1550 during the Portuguese occupations. In 1795, British had decided to destroy the entire fort by using gunpowder. Luckily, Sir Stamford Raffles, founder of modern Singapore, right, have saved this particular structure, Porta de Santiago. Okay, and then the fortress left gate, which mainly built using laterite stones, is one of the substantial trace for this particular fortress town main entrance. It came into Melaka. I still remember that Mr. Sakamoto saying that and few friends from the Japan and Japanese counterpart saying that they visited Melaka 20 years or ago. So still this particular gate is still standably strong, okay, and it still stands on this current location or site. So this particular Porta de Santiago, gate of Porta de Santiago, has been conserved as one of the project with St. Paul Church with the same budget allocation in 2012. So when they go into the how practical the environmental maintenance impact or evaluation or EMI, I want to show the practical examples based on the three main case studies. So one is St. Paul Church. What I want to highlight from this particular table is that, okay, right, in the items of repair techniques, materials, their respective descriptions, the quantity of in terms of meter square of wall repair, total area repair as well as mass per area repair kg in terms of mass. So for different repair technique, you can see what's the material have been used, and then what's the descriptions, what is the quantities, kgs, and where the area and so forth, as you can see from this particular slides. What I try to highlight is that, okay, of course, for this particular St. Paul Church, right, they are using normally about 90 units bricks blocks, okay, and so with the respective about 2.13 kg of every single bricks block. So you can see the other material, jointing material, lime, sand, and brick dust. All right, with regards to the mixture or the proportions, normally is 113 or something like that. So you can see it's influencing the quantity, mass kg of the material, whereby why I want to show is that for different repair technique, of course, they're having a different materials usage as well as descriptions, as well as influencing the other aspect of the quantities, total area repair, as well as mass kg of area. Sorry, this mass kg of area repair for a material use for entire building. Okay, for the CS2 comparatively, as you can see, because it involves a construction technique only. Okay, is during this particular reconstruction, laterite stones using a Dutch and Portuguese specifications, like layered by about 20 mm width and depth. Okay, so want to highlight is that, okay, one single block about 100 kg, so it's very heavy. So as you can see, that's why the totals of the quantity repair areas and so forth, mass kg will be highest as nearly here is 2 million for overall fortification of bestial Medibra and its reconstruction. Last case studies for the comparative is gate of Porta de Santiago. For this particular gate of Porta de Santiago, having stone replacement, repeated plastic repair, as well as repeated pointing against, right, using the bricks, okay, as opposed to the second case study, which is multimedia using laterite stone. As you can see, quite less as compared to in terms of the quantity area repaired, as well as mass per area repaired kg. All right, for this particular environmental impact evaluation, we do adopted embodied carbon coefficients. Normally, we are referring from inventory of carbon energy ICE from Bath University. If you can see over here, the different embedded carbon coefficients from different material used for the conservation of 3 case studies I mentioned just now, representing the embedded energy. The higher the value of ECC, means the more energy used during the manufacturing process. So why we do referring to ICE in UK, for example, if you're talking about you are talking about in terms of the technological advancement, energy usage, okay, the technological grids of electricity and so forth, quite similar to Malaysian context. So in terms of the ECC, the production of this particular material is quite similar with regards to the manufacturing and so forth. Okay, one of the important factors need to be considered during these studies is that how material resourcing locations can influencing the MI. So, for example, as comparative for 3 case studies, right? I just want to highlight is that the imported material for this particular CS2 Bastian Medebe, right, because it's imported from Prachinburi region in Thailand, okay? And then need to be delivered at Melaka over here to the southern part of the regions, right? Malaya, right? So distance for delivery of the laterite stones nearly 2,000 kilometers as compared to the locally sourced bricks for St. Paul as well as for the Porta de Santiago. So again, one to highlight is that it's a very significant over here is that imported materials will influencing much in terms of environmental impacts evaluations, because the further the distance will, the higher the carbon emissions involved during the transportation of material to building site. So if you look into these particular 3 case studies, okay, very significant, very obvious. Okay, laterite stones is imported material. The rest, some of the jointing material, for examples, for both, for all of the 3 using the limes resource from Perak, and the rest is material is resource surrounding or just surrounding the Malacca area. Okay, for in terms of the assessment of EMI, one of the important factor need to be considered is transportation data. For this particular studies, we do refer to this DEFRA 2019. Emission factors they are adopted for the calculation of EMI is during the transportation or get to site of the LCA is for the transportation of laterite stones in particular. We do as well as other material is for the 3 axles of trailer or trucks, okay, that emitted about 126 grams CO2 emission for every ton of kilometers or material delivered to building sites. So again, so when it comes into MI, we need to consider in terms of repair techniques with the different scenario, with different longevity of repair. For example, in the case of scenario time frames, of course, replacement is nearly 100, repointing is about 30 years. There's a combination, so for example, pinning, consolidation, and replacement, as well as plastic repair, as well as replacement. Not all scenario can be a combination. The reasoning for that is due to the heritage conservation practicality. For example, once the plastic repair is up to the level of the age, right, need to replace, and then whenever the demyelinations of the crumble of the surface, then you need to use the plastic repair. So the process of combination is simultaneously or continuously is a combination, as well as spinning consolidation as well can be combined with replacement. Not all the other techniques can be or practically combined. For example, repointing, this is not worth for us to do repointing followed by the replacements, because pointing is just merely to do the pointing repair. So it's not really impacting the overall structure with regard you do the replacement of the material. Right. In general, when we do the result testing, right, what we can generate from the total environmental maintenance impacts, EMI, or kg CO2 emissions for every meter square or kg or mass of kg materials. Okay, so we can identify best repair strategies in terms of EMI, but we need to consider, for example, the result then shown to us is that, right, the stone replacement and any combination with stone replacement, for example, from this particular graph, right, or table that's shown to us is that scenario 1, stone replacement, as well as consideration, then stone replacement combinations shows us the most ideal with regards to the best repair strategies in the facet of MI. The reason is that they have the longest longevity, as well as the most sustainable techniques with regards to the aspect of green maintenance model. So by doing so, we need to consider as well as technical considerations during the LCA process. We need to set clearly the cradle to get to site and cradle to site boundary, or LCA. So different longevity either of the repair techniques, for example, in relation to longevity of years, for example, stone replacement merely up to 100 years or beyond. Reconstruction techniques up to 100, plastic repair merely 30, repointing 25, and pinning and consolidation just 20 years of longevity or repair. So of course, we all know also need to consider how much how large the area to be repaired, as well as what the repair material have been used in terms of the profile, as well as quality of repair. Again, if you look into the graphic representation or this particular graphics, right? So what we can say is that, okay, for every meter square in 100 years, and the totals on 100 years, as you can see, again, the most ideal against repair techniques if repair technique for scenario 1 and as well as scenario 4. Okay, so summary of the findings. Okay, the key items, as you can see, I just want to highlight a few key findings or key items based on repair material selection quality. We found that about 1 kg or per meter square. Okay, is differences between a compatible cement-based mortar and a compatible lime-based mortar. For example, you can see this is using the cement base, right? So you can see it's not really compatible, right? So of course, we do highly encourage to use a lime-based mortar. So that's the differences. Okay, can be lowered down in terms of the emissions of every meter squared. The less the repair mean, the less carbon emissions being expended during the repair. As well as embedded carbon emission value will influence the result. For example, limes merely 0.78 as compared to cement. The higher the energy used to the production of material, for example, in the case of cement, the higher the EMI. Of course, we need to consider either the material can be recycled. In the case of laterite stone, some of the reconstructions or repair maintenance using the salvage material. So, of course, for example, we do also can use the brick dust that can be resourced from the site. So it can assist about 3% of reduction of emissions, EMI, as well as for the plastic repair up to 7% if you are using the recycling approach, for example, using brick dust. Of course, again, imported versus local material. Of course, imported material contribute to high CO2 emission. For example, 100 kg of laterite block versus 2.13 per kg of bricks, and then resourcing distances. For example, laterite stone from Prachaburi, Thailand, that's nearly to 1,100 kilometers, as compared to local bricks, just resource from 15.6 kilometers, will influencing the the finals MI. So having to say that, we need to consider as well conservation philosophy of stone replacement. Of course, brick versus laterite stone, we need to consider like for like material. We need to be honest. All the repaired material or structures need to be distinguishability. And that's as possible promote the local material usage. Of course, all our quarry of Pulau Upe is closed as for now, but in the future should be there is economic studies whether there's an economic opportunity, these available, whether in a small scale conservation might be the reopening of local quarry. An example of Pulau Upe can be done in the future to accommodate the demand of local laterite stone for repair in Malacca all heritage set area. Okay, the third one is how MI outweigh the cost. Either the MI having the merit or demerit with regards to the cost performance. Yeah, this construction evaluate into the case of Bastian Middleburg CS2. All right, the construction over here involve more than 1.2 millions, okay, ringgit Malaysia, right, per intervention, as well as very high in terms of CO2 emission. In terms of cost efficiency, combination of stone replacement strategies reduce almost 90% of repair costs. If compared, right, scenario 1 and scenario 6, okay, it's almost right 90% less, almost right, reduce 90% of the overall total cost. So with regards to the concluding comments, I would like to say, of course, green maintenance models able to quantify the evaluation of the efficiency of the carbon emissions. Okay, of course, we need to have a validation sensitivity analysis. Okay, so this will be solved probably as cost-oriented decision making, as well as to do the research can be applicable to other historical sites all over the world. Just a few slides to go on. I will be very quick. So in terms of my evaluation, I want to share a bit in terms of practical example or success stories. We do have complete the quantifications of green maintenance model, okay, on the embedded carbon industry. A case study of heritage building construction in Malaya, completed in 2017. Okay, have been shared in terms of the output either in international conference, have been disseminated through the output of high peer review journal as well. Okay, right. So just recently, we do have a collaboration with our counterparts from Universiti Shah Kuala. We do have a kajian dampak konservasi cagar budaya terhadap lingkungan melalui pendekatan MI, or the study of impact of conservation of cultural heritage, building and environmental through the MI. Both sites in Gunungan in Aceh, Banda Aceh, as well in Melaka Historical City Center. One of the significant output is Scopus quartile journals have been published from this particular collaboration research effort. I also had disseminated or produced my works that mainly on the MI from my books in 2020. I do have produced one's books published by Press, as well as just recently in 2022, another books on heritage building conservation. You are most welcome if you want to get into the copies, okay, from this particular platform. And how do we look away forward low carbon cost repair and heritage conservation? Now, myself as principal leader, having ongoing research. One of the participants, Siti Norbaya, is one of my research team member as a graduate research assistant on low carbon cost heritage building restoration to integrate environmental and cost impact appraisal on the land-based mortar intending green growth at Malaysian UNESCO World Heritage Sites. Currently is an ongoing project, okay, expected to completed in 2024 next year, April. Okay, what I want to say is that the combinations of my co-researcher is from various expertise, from engineering and structural dynamic scientists, material engineering scientists, material scientists, conservation expert, as well as technology, as well as management expert in this particular area. Of course, this is supported by partnering university, University Malaya, UniKL, University Science Malaysia, as well as Harvard University. Collaborative partners including all of the conservation organization, either in Malacca, MRISM, okay, Perbadanan Teknologi Hijau Melaka, Malacca Technology, Green Technological Corporations, Georgetown World Heritage Town Incorporated, Penang Heritage Trust, as well as other innovative players, comprises of National Heritage Departments, Malacca World Heritage, Seberang Pride, we call local authority, as well as Malacca authority, covering all the World Heritage Site of Malacca and Georgetown and Penang. So last but not least, what I try to say is that with regards to heritage building conservation, I always get into the philosophy of, in Malay terms, we call it patah tumbuh hilang tidak berganti. In English, can be parable to into once the heritage building is lost forever. Even though we can reconstruct, okay, regenerate, restore whatsoever, but the originals authenticity, the value of the building will decrease over time if there are no low carbon repair or sustainable repair approach have been undertaken in the longer run. So I will leave it to you all to share with these particular terms. Patah tumbuh hilang tidak berganti. Once it lost, it's lost forever with regard to heritage building and heritage structure. So with that, terima kasih, arigato, sise, and thank you. So I will welcome all of the questions, queries. If there is any, I try my best to respond to any queries that you raise up after this. Thank you for your time. Thank you.
Terima kasih banyak, Brit. We got some questions at the chat window. For example, why in the case of case study 3, why did you import laterite from Thailand?
Okay, that's a very, very good question. During the conservation process in 2008, the major reconstruction of that fortification of Bastion Medeba, okay, there are not sufficient local produced laterite stone. Remember I mentioned about Pulau Upe, Upe Islands. The treasure quarry is closed long time ago because it's not very economic with regards to the operation cost and so forth. So when the teams do the profile studies, okay, the most similar with regards to the conservation philosophy, like to like material, the nearest profile when they do the testing, lab testing and so forth, in terms of appearance, color, formation and so forth, the nearest one is from Prachinburi, Thailand. So that's why the National Heritage Department or Jabatan Warisan Negara at that particular time decided to import the material from Prachinburi in bulk, because the quarry that operated in Prachinburi region in Thailand is a large scale of operation of producing the laterite stones. So that's the one of the reason. Of course, if you look into the actual chemical profile, yes, if you're talking about in terms of me as a conservator, I prefer the locally sourced material. But again, with regards to the building conservation philosophy, there should be a compromise. We need to, let's say, compromise in terms of technology as well as materials, as long as it's very similar to the original in terms of the profiles, the technology advancements can enable the reconstructions techniques can be done to the of the fortification of bastion medieval.
I see. Thank you, Brit.
Mm.
Similar things happens here in Japan also. When we reconstruct big temple or shrines, and if we cannot find good materials, timbers, we import timbers from Taiwan sometimes.
Yeah,
Yeah.
I'm quite agree on that because several building, I also investigated several timber building in Malacca in particular. We do have imported timber material from our neighboring country, Indonesia, because the timber production in Malaysia, even though we do have the same species or same grade or same types of timber, but in terms of the integrity, the age, the maturity of the timber is not similar to the original Malaysian timber. So, of course, of talking about in terms of currency exchange, and then the nearest that we can resource is from the neighboring country of Indonesia. So it's still allowable as long as we can achieve as similar the nearest that we can get in terms of the species, the grade, and so forth.
Okay, thank you, Brit. And another question left in the chatting window is, say, this is a historical issue. To the Malaysia, Portuguese came and Dutch came and British came. And his question is, which occupation was most significant or strongest impact?
Okay, this is my not to say view of academics per se, but from my observation, my personal point of view is that
Yes, of course.
there's the most significant impact if you're talking about in terms of the current states of the historical structures, in particular, for example, a Formosa, St. Paul Church, as well as Bastion Medieval, all the three case studies I mentioned just now is that during the British occupation. The reason I'm saying that, okay, during the British occupation, particularly during the Second World War, right? During the Japanese occupation, before the British surrendered to the Japanese, they bombing the Malacca fort. They destroyed all the structures with the bomb.
Oh.
So yes, so when the reconstructions or regeneration of that area, okay, just partials of the lateral stone used as salvage material can be done. Only partial, not all, not all. So I would say if you're talking in terms of laterite stones, the most significant impact, of course, is in negative way to say. The destruction is much happened during the British occupation for the second time after the Second World War. But if you look in terms of originality, right? In terms of structures, appearance, authenticity of the style and so forth, yes, I would like to say is during the Dutch occupation.
I see.
As you can see from, for example, Christchurch State House, you can see large area or most of the part of the building still you can see the influences of Dutch very obvious. So until now, you can see in terms of the either is a construction techniques, material, and so forth, apparent can be seen clearly on the Dutch building rather than British or Portuguese building as well as the British building. Of course, the newest age, for example, during the British occupation, during the 20s, 90s, there is a series of heritage building structures built by the British. Of course, it's quite obvious of the British, but again, in terms of the originality, I would say British building more renovation have been done throughout the years as compared to the Dutch or Portuguese building in Malacca.
Okay, thank you. So now this question and answer session is open to everybody. Anybody has a question to Mr. Brit? Nobody? Brit, I have a small question. The
Okay.
word of Formosa.
Mm-hmm.
In my understanding, Formosa means Taiwan.
Mm-hmm.
So, and you have also Formosa in Malaysia.
Okay.
So,
I am as far as I'm know into the historical evidence of fact. I'm not sure where, but Formosa is if you look into the Formosa itself,
hmm.
it's the entire fortification of the fort, not only the Forta de Santiago. Forta de Santiago is one of the gate that still remain intact. Actually, that's why one of the case study is, you see, I show you the Bastion Medieval. That's a fortification throughout the fort. So Forta Santiago is one of the main structure. But throughout the years, the historical evidence referred the A Famosa as the Forta de Santiago, which is, if you look into the perspective of the entire area, is considered as a Formosa is a fort, the entire fort. Yeah, not the Forta de Santiago. I'm not really sure you mentioning about the Formosa is from Taiwan or whatever. Most probably, yes, because Malacca itself, they have the economic trade with various countries at that particular time. Even, for example, certain area in Malacca, in terms of street names, of course, and very obvious as well, the buildings, the street names, or the still referring to during the colonial time. For example, even though they're having a Malaysian name, but they are still referring to the, for example, during the Dutch era, they're having the Herian Street, but it's a Malaysian name is a Chenglok Street. So, but again, the influence in terms of historical evidence and fact, local people aware about that. Might be lah. If you ask me for the opinion, should be in terms of historical evidence should be well established as well as aligned to each other, so that to provide us a better understanding in terms of reference, any building, structures, street, and so forth.
Okay, thank you. Another question has come. What does it mean, plastic repair? Does plastic repair means lime mortar?
Plastic repair in terms of the, it's not using plastic, yeah. That those don't misconception. When it comes into the construction techniques, particular heritage building conservation, plastic repair is, if you look into the new build construction, is plastering. It's the same thing. Yes, because of the plasticity characteristic of the lime-based mortar material used, that's why the term used is a plastic repair.
I see, I see.
Yes.
Okay, and why did... Any questions? Brit, your theory, environmental maintenance impact evaluation, I think this is this can be applied to any kind of laterite structures, not only for the heritage, but also for any kind of laterite structures.
Okay. If talking about environmental maintenance impacts, when I'm mentioning about the use stage of either as a building, whatever, the last span of the buildings, right? During the maintenance phase, for example, because any building, doesn't matter whether it's a heritage building, either they are using laterite or either they are any material, as long as they're having the maintenance phase, right? Usage stage. So we can always quantify whenever any structure, any material, any elements through the repairing process. So MI is applicable Okay, because I also do MEI for heritage building, but with the new additional of new build extensions. So it is applicable not only for the heritage building, but can be to any types, any form, any designs, any material, as long as that particular structures or building having through the maintenance phase of the lifespan. So we can use the environmental maintenance impact. The keyword is maintenance. So mean to say, as long as the building or structure or elements going through the or undertaken the repair or maintenance, the MEI can be what we call applicable.
Okay. Say, laterite structure in Japan, we have very few laterite structure. So my question is, say, for the modern structure, do you use in Malaysia? Do you use laterite as a building?
As far as I know, one of course the prices, of course, is very high, quite high to say.
I see.
And then if you're looking into the large scale of production, there are no more in Malaysia. There are no local quarry anymore in Malaysia. Like I said, yeah, in the case of let's say Bastian Medeba, the nearest that we can resource is from Thailand. That's the nearest. And then that's the, of course, because when it's the nearest, the overall total cost of resourcing of the material, that's the lowest that we can get. So if you're looking into new build, it's not really economic to say for the new build. It's not really economic to say for the new build. Because when it comes into the applications, cost-wise, it's quite expensive to say in terms of repairing or replacing and so forth. And then the niche market of laterite stone in Malaysia nearly to non-exist as for now.
I see. So when you discuss about laterite structure, it's almost always a heritage structure.
Yes, because the one that still exists as for now all over throughout Malaysia, I saw one view of the slides all over Malaysia. That one is showing us the currently existing structure, including historical structure that still exists in Malaysian context. So I would say for the new build, as for now, as far as I'm doing my studies on laterite stone, there are no new structure or construction using the laterite stone. Back to my rationale is that economic-wise, it's not really economic because maintenance, repair is very expensive. And then one of the main reasons is that not very much in terms of the niche market skills as well to do the laying and so forth. That you need to specialized skill to particularly in using the lime mortar pointing.
Okay, thank you. Okay, any other questions? Ladies? No questions? Gentlemen? No question? Okay, so we used 100 minutes. If you have or any comments, not only questions, but also comments are welcome.
坂本さん、
はいはい。
僕ちょっと前に質問したんですけども、
はい。
植栽と建物の関係の評価でですね、
はい。
僕が聞き逃したのかわからないけども、要するに温熱評価も含めたですね、カーボンニュートラルという話はあったのかどうなのかということ。 です。
建物、今回は建物というより、あれですよね。
グリーンという表現はあれ、緑、植栽っていうことだったんじゃないんですかね。それちょっと僕わからなかった。
Brit, here is a
Yeah.
question that when you say green, what does it mean? Is it planting or carbon emission?
It's a carbon emissions.
Carbon emission. So green means something gentle to the environment.
Yes. But with regard into the quantification, carbon emissions is in the form of embedded carbon expenditure expended for repair.
I see, I see. OK. just a moment. 上島さん、それ植栽の話じゃなくて、
そうか。
地球に優しいという、そういう意味ですね。
そういう意味ですね。
はい。二酸化炭素排出量の話でした。
わかりました。
ちょっと紛らわしかったですね。はい。OK. Anybody comments or question? If there is no more questions, shall we close our session today? Okay, thank you, Brit. Anak means son, huh?
Yeah, Anak is a son of.
Son of. So your father's name is Kayan.
Yeah, my father's name is Kayan.
Uh-huh.
But in Malaysia, Anak is for the what do you call it? It's some sort of like aborigines.
Origins.
Yeah, aborigines, like aborigines.
Aborigine.
We are originally
I see.
communities, yes.
Bumiputra.
Yeah, we are
I see, I see.
yes.
Okay, okay.
But I'm from the Sea Dayak community clan. Sea Dayak is from Borneo Island, Sarawak.
You are from Borneo
Yes.
Island. Your ancestor.
Yes.
Okay. Thank you, Mr. Brit. Anak Kayang. Okay.
Again, I would like to say extend my appreciations for the times, for the questions, anything. If you have any queries, to further to discuss, or maybe you have queries but you don't have an opportunity to ask during this presentation, you can always send me an email, shoot me an email. If you have further questions that need more elaborations, further discussion, I would more than happy to share my opinions or my thoughts for any queries. Again, Mr. Sakamoto, my appreciations for you and the team. I'm very feel humble with this opportunity given by you. Seeing all of you is expert in this heritage conservation. I'm quite so novice to say. I'm quite new to this particular aspect, but I have a patience, a similar patience to looking after the heritage, particularly in Malaysian context. So in the future, I'm also looking forward to learn from you all, might be from Japanese context or in other country. So how the best practice can be done, in particularly to protecting or safeguarding the heritage building or heritage structure. Again, thanks so much for the time for all the participants. Wish you get the new knowledge for today that we are shared together. Again, thank you so much.
Okay, thank you very much, Mr. Brit. And to all the participants, thank you very much for your participation. Okay. Okay, now we are closing our session today. Okay, bye-bye.